to review what happened in broom ball activity during class. If you haven't watched the video that's posted with this assignment, I would encourage you to do that beforehand. So the first thing they ask us to do is sketch the track. And we started back in the back of the classroom by the silver sink. And to do that, we had to go towards the center of the classroom or towards the windows and then make a sharp right turn. From there, students went along a straight path to the inside of this first cone where they had to make a right turn clover leaf around the cone and then had to go past the second cone up by the smartboard and make a sharp left-hand turn. As they headed back towards the lab part of the room, there was a no-touch zone or no strike zone. It says in the directions here, where students were not allowed to move or push on the ball before bringing it back right in front of the black sink, where they brought the bowling ball to a stop. And they could only use the bristles of the broom as they went through the obstacle course and weren't allowed to bang into cones that were set up along the way or into tables or chairs or even the feet. There was a penalty for each thing that students ran into or for getting off course that was added to their score. And the idea was to get the lowest possible time and lowest possible score. So for number 2, it says, what were the rules? Well, we just kind of went through those. So what were the rules for broom ball? Using only the bristles of the broom, guide the bowling ball through the obstacle course in the least amount of time while maintaining control of the ball. 10-second penalties were added for hitting the cone to your feet or getting off course. As students progressed through this, they found out this was far more challenging than they originally thought. One of the things that surprised students the most was the mass of the ball, and some of them described it with how heavy the ball was made it difficult to change what it was doing. The 3 things that were most challenging with the ball were speeding up, slowing down, and changing direction, which happen to be the 3 ways that an object can accelerate, right? And the reason that it was difficult to speed up or slow down or change direction because the ball had a ton of mass, well, I shouldn't say a ton, but it had a lot of mass, which also means it had a lot of inertia. Inertia is the concept that an object's going to keep doing what it's doing. If it's at rest, it would like to keep at rest. If it's moving, it would like to keep moving in the direction and speed it's going, and it takes some sort of significant additional force to change its motion. How can a player use the broom to overcome the difficulties listed up here? Well, in order to get something to speed up, you had to push the ball in the direction you would like it to speed up. In order to slow it down, the ball had to be pushed in the opposite direction that it was moving. And to move it in a circle, people had to use the broom bristles to push the ball towards the center of the circle. Finally, it asked, how did the ball move through the no-strike zone? What caused the motion of the ball through the no-strike zone? Well, it's important to realize that the ball was already moving before it reached the no-strike zone. All right, and in this no-strike zone, the ball moved at a constant velocity. It moved at the same speed and same direction. And this is because an object in motion remains in motion until a net force acts upon it, which is a portion of Newton's first law. We also took a look and drew up force diagrams for these 3 items: to speed up, to slow down, and to change direction. One of the classes we might have looked at a constant velocity as well. In other words, for an object to remain at rest or move at a constant velocity, the forces have to be balanced. But in order for something to speed up or to slow down or to change direction, which is what happens when it moves in a circle, the forces have to be imbalanced. There has to be an imbalanced force or a net force. I hope that helps.